So, let me shortly introduce myself. I'm Marco Möller, CEO of MAVinci. We are a German UAV manufacturer, and we are bringing you the full solution for capturing aerial data. Full solution means that you have the whole tool chain, starting with flight planning, going over the image acquisition, generation of autophoto on DM, and finally analyzing these tools. My talk will also guide it on this line, so let's start with some flight planning. Imagine you have your mission site. It's somewhere on the globe. First, you have to find your mission site on the globe. For this, it's good to have some good maps already in your software where you can orientate yourself. Then you click some rectangular together and select the area of interest, and then you need a flight plan. So what's needed for a flight plan is the ground sampling distance, so that's determined by the flying altitude, and you need overlap between different images in one line, and you also need overlap between two different lines. And finally, you have some area where the overlap is as high as possible. This is only your area of interest. So you clicking this rectangular, and the software makes flight lines out of this. This is already solved automatically. That's one click for you. You don't have to think about, but it's good to know the background. So, but what happens if your area of interest isn't a rectangular? So we're also supporting arbitrary polygons, which will save you a lot of flight time, mission time, and basically your money. Next, what could happen is if you're flying really low or you need a really big side overlap, every UAV has a certain turn radius, every fixed wing UAV. And by doing this, if you're just flying line by line, you have areas which are not covered as good as they should. And we have solved also this. So we are not flying line by line. We are jumping between different lines to solve this problem for you. Even you don't have to think about it. Next thing what could happen in doing a flight plan is if you have hilly terrain, you're flying on a constant altitude. You see the overlap is here, everything as planned. If the terrain climbs, your overlap becomes smaller and smaller. And here you even get gaps in the area of interest. So this spot is not covered at all. On the other side, the spots on a valley are really covered much more than you actually need, which will increase your processing time because you have basically too many images. In our software, which is full 3D, you can see such a constant flight altitude flight plan also from the side. You see that's not quite optimal. Something like that would be much better. And also this is done automatically by our software for you. Our software is asking you, oh, it's a hilly terrain. Do you like me to fix this for you? And if you say yes, you get a terrain flight plan. And afterwards, you can get a coverage preview instantly, 2 seconds after you get your flight plan. And here you see everything is green, everything is covered as it should. Next question, what if you have a really large mission site? So I have here basically the same area as before. So this would fit in one flight plan, but you also could split it. And if it's become too large, the software will also suggest the splitting for you. And then you have done this in 2 or maybe in 10 or 20 different flights. And the overlap between the flights will be as small as possible, but not smaller. So you have a perfect overlap without wasting flight time. So this is the part about planning your flight. Next part will be only roughly about flying the mission. You're launching the UAV, you're flying it, you're landing it. Launching is done by us manually in hand launch mode. So, no, not manually, by your hands. So you're putting the UAV in your hands, pressing the engine button, wait 2 seconds, the engine will start, and you only open your hands and will climb with 40 degrees into the air. So you don't need any catapult. You have no material what you have to carry with you. You don't have any mounting time for the catapult. It will save you a lot of time. During the flight is automatically. But in many countries, you are forced by law to have emergency backup system. So In Germany, for example, you have to be able to fly manually, which would be really difficult for you to doing. So to learn to fly manual would take you, I don't know, 3 months and 3 UAVs to learn it. So for that reason, we integrated an assisted mode, which means you're steering left, right, up, down. And if you don't steer, it flies just straight forward until it crashes against a virtual wall and comes back to you. So it can even not fly away in this mode. And in this assisted mode, for example, you can fly away from a rescue helicopter. You can even land in this assisted mode. We are also supporting manual flying mode. We're also supporting automatic landing, which will work really good if you have enough space and no obstacles on the ground. But if you have stones on the ground, bigger rocks or some trees, or you have to land on a small road between water, this wouldn't be possible automatically. For that reason, you can also land with this assisted mode. And it's quite easy. If you like, you can try out yourself outside. We have a live demo I will show you afterwards. So, and other short facts about our flight is that we have a really durable system. It's a special foam material what's really strong against breaking, and if it's break, you can glue it really easily together again. So we have really small spare part costs for you. We calculated it with about 18 euros for every landing, which includes also the battery, which is the hugest part, because normal UAV batteries will be end of life after 50 flights, because they are really lightweight and they're optimized to have a high power and to be lightweight. So you have to reduce the lifetime, otherwise you couldn't achieve that goal. It's easy to use, and we even operate with in strong wind and even in rain. So this wouldn't be a problem for us. In one flight, which is about 45 minutes plus 10 minutes, we have a safety reserve in the battery. You can cover at 1.6 centimeters between 70 hectares and 162 hectares. It depends on which overlap requirements do you have. If you need a really good 3D model, you stay with the 70 hectares. If you only need a rough 3D model, you can do up to 160 hectares. On the highest level, what's basically legal, depends on the country, you can do it between 800 and 1,800 hectares in one flight. And then you land, need some minutes to drive with your car to the next spot. You're starting again, you just change the battery, and in this short time you can do a lot of missions in one day. So after the landing, you're copying the data to your PC. It's done within minutes. You get an automatically pre-check of the coverage. You see here the green coverage, which means here's everything okay. Here's orange, which means, yeah, you get somehow a 3D model, and red on the outside means you don't get any 3D model. Basically, our mission was only the inner green area, but I extended it here for you so that you can see the different colors. You get this within minutes. What's really important for you, because don't having this information in the field will mean that you only check afterwards in the office after some days of post-processing if you captured all your data, which you actually need. And if you're doing, let's say, one campaign week overseas, going back to your office and then realize that you have lost some data would be really, really expensive for you. And a lot of customers are doing such missions from us, and so it's a key feature. And we have post-processing interfaces to many different post-processing solutions. And yeah, so we have different options for you. We have some of them really tight integrated. So for example, Agisoft, there's a special MAVinci plugin what eases up the work with Agisoft for you. And finally, after checking the images on the ground, you also can check if they are really sharp. So this was 1.6 centimeter ground sampling distance. So that was the size of the pixels in your camera. But we have checked on this mark that we can even see spots up to 1.8 centimeters, what's incredible sharp. So normally if I do this with my smartphone camera, I can promise you, if I calculate 1.6 centimeters, the real resolution will be maybe 10 or 20, because the CCDs are that small, the lenses are really bad. So ground sampling distance isn't the same always. So you have to take a look on the camera which was used. Next step, post-processing. So what you actually do is you're taking the UAV positions and the images throw it in some post-processing black box, you get out an autophoto, and DTM, a point cloud. And if you want to do this really exact, you need ground control points. That means you spray on the ground some crosses, measure position of the cross, put this into the post-processing, the positions, and mark the ground control points in the images. And then you get really good results. To validate the results, you need basically other ground control points and do a validation if they are also reproduced correctly. If you're using the same, that would be a really bad idea, because if you're doing the optimization of the model on the same point where you're doing the cross-check, you will basically get better results than you actually have. The rule of thumb for more or less for most UAVs, if you have a really good camera, is 2 times the ground sampling distance as error in X and Y, and 3 times in Z. I call it the old rule because we have something new to present. And here you can basically see why. So if you do this ground control points with GPS, what's basically inside the UAV, you have 15 meters accuracy. If you're in Europe or in some other countries where you have the S-bus system, you maybe get 2 meters. So you're averaging over a lot of that points. So basically your error will only be 1 meter. So the whole model will be shifted by 1 meter, stretched by 1 meter, maybe a little bit rotated. But if you could do the reference with RTK, which is sub-centimeter accurate, you get a really, really impressive accuracy. And we have done this, and we are able to do 5 centimeter accuracy even without any ground control points. And without ground control points will save you a lot of mission time, because you don't have to walk around. You don't have to mark these ground control points in the images. So that's something no UAV has ever done this on the market. So that's a MAVinci feature. We have done this together with Topcon. We are using their 100 Hertz sub-centimeter grade receivers. They are fully integrated ATK. We can receive every channel from the major GNSS systems. And how does it actually work? So normally you have your mission site, and you have placed here, let's say, so that's really a lot. Let's say that's 50 ground control points. That's a lot of the work to do. Normal missions I've seen have maybe 5 or 10 ground control points. And having less ground control points means it will be not that good. So having so much will be really a lot of work for you. So imagine if you have 1,000 ground control points equally distributed over the whole project, like this. So they're not on the ground, they are in the air by using this RTK. So what we are doing is we have one reference station, what you need anyway for steering the UAV, and this is additionally RTK reference station, and helps to locate the UAV incredibly accurate. And so by doing this, you get this high accurate results. Maybe in some places you are not able to place ground control points. For example, if you have quicksand, or you have to make a 3D model of some mining deposit sites, you're not allowed to step there, so you can't place ground control points over there. But they need accurate models, and it's only possible by doing it without. And we have the solution for this. And you basically remove a big error source, but if you're placing manual ground control points, you can do a lot of wrong. So, and if you not have to do it, for example, here some images, we have 2 different flights of the same area, and there was maybe 5 hours between the 2 different flights. So this car was moved, the truck wasn't moved, the digger, and you see that even the roads, the wheel signs on the ground, you don't see any inaccuracy on the cut line between the 2 different flights. And if you're an expert on the 3D stuff, you know that something like trucks are awful to reproduce by normal post-processing. And you maybe see little color differences here because of different lightings, but the 3D model fits perfectly together between the different flights. So you have incredible reproducibility. So, and something what everyone is interesting to know is the accuracy. So our new rule of thumb is getting the same X and Y and Z accuracy like the ground sampling distance. It's roughly, so we are still a little bit increasing this. we have done up to now, or we have done a lot of projects. We have evaluated 6 different of them. And for example, here's the ground sampling distance, what we have done, and here's the X and Y accuracy. So you see it's in the range of the ground sampling distance. For high ground sampling distance, it's even below. Because the GPS error will not increase if you're flying higher. You always get this sub-centimeter range. And the Z accuracy is normally worse than X and Y on the normal post-processing. Here, we are even better in the elevation than with the normal ground control point stuff. And here you see this validation point. We have sprayed across on the ground. We have measured the position, but we don't talk our software about this ground control. And afterwards, we checked it, and it's lying perfectly on each other, up to 1 pixel inaccuracy. So if you want to see more about this data, come to our booth. We have a lot of example data over there. We also uploading this data into the web in the next days. And if you want to see it live, please visit us on the outside. We have a live demo area right here in the Gruger Park. You can come over. You can try the flight planning on our booth or outside. You can do the takeoff by yourself. You can do the flight. You can try out the assisted mode. You can help with landing. You can do the quality check. Everything here. I think we are the only fixed-wing UAV which one competitor told us we are brave enough for doing this live. So for us, it's not brave enough. We think it's normal because it's a product, it works, and we not have any fear to let you try out yourself without any big introduction. So, and you can grab your beer or sausage if you like. You are introduced. Welcome. So, thank you for your attention.